let's look at the trickiest question on this paper 1H, the IGCSE paper from May 2023. It was question 23. This was the hardest question on the paper. You can see that most candidates scored less than 1 mark on average. So most people scored 0 on this particular question. Let's see if we can solve it. So we've got a frustum. That's this 3D object that we've got here on the diagram. And it's made by removing a small square-based pyramid, namely this shape here, from a similar large square-based pyramid shown highlighted here on the diagram. Now these are similar shapes, so one is just an enlargement of the other, and we should note that they're both square-based pyramids. So we can see here we've got a square on the base here, all of these are 39, and similarly for this pyramid this is also a square. So thinking about those similar shapes, maybe we can work out some lengths. Let's draw out those two pyramids separately. Here they are, here's one I prepared earlier. Notice that because these are similar, we can work out the length scale factor. So hopefully you can note that to go from 15 to 45, this way we would multiply by 3. 45 divided by 15 gives us 3. So going this way we are dividing by 3, going the other way we're multiplying by 3. So if I want to work out this length here, the length of this smaller square-based pyramid, all I need to do is divide this corresponding length, 39, by the length scale factor. Divide it by 3. So that's exactly what I'm going to do. 39 divided by 3 gives me 13. So remember, this was a square-based pyramid, so both of these lengths here are each 13. Okay, let's have a look at the question. What are we trying to do here? Well, we're trying to work out the total surface area of the frustum. So the frustum, remember, is just this object that we've got here at the bottom that's left after we've removed that pyramid from the top. And we're not finding the volume, be careful, we're finding the total surface area. So let's think about the different surfaces of this shape. Well, we've got this 13 by 13 square at the top. We've got another square on the base, that's a 39 by 39 square. And then we've got 4 identical trapezia. So here's one such trapezium here. You can see we've got another one here that would be identical, and then we've got another one around the back, and then we've got another one on the side. They're all congruent, they're all exactly the same. So let's just draw out one of them and think about what we would need to know to work out its area. So to work out the area of a trapezium like this, we need to use the formula half of a plus b multiplied by h, where, let's think about what a, b and h represent in this shape, this trapezium. A and b are the two parallel sides, and h is the perpendicular height, so the height at 90 degrees to each of those lengths. So how are we going to work out this perpendicular height? Let's show it on the diagram. Well, it's going to be quite tricky to work that out directly, but we can use a right angle triangle to help us to work it out. In fact, I'm going to draw in a right angle triangle right from the top of this shape all the way down to the base here, and there we go, there's our right angle here. I'm just going to label this shape A, B, C, and I'm going to note that this vertical height here of this shape is 45, and this length here will be precisely half of this length here. So if we divide 39 by 2, we get a length here, AB, of 19.5. Let's draw out that triangle and see what we can work out. So here's a triangle that I've prepared earlier with some calculations. So there's the triangle, and I'm going to use Pythagoras here to work out the length of this hypotenuse. So I've just used Pythagoras' theorem. We square this side, add them together, and then don't forget to take the square root. I've stored that number in my calculator. Now, that's not actually the length that I'm looking for. I'm not looking for this entire length. All I really want is this length here, because that's the perpendicular height of the trapezium. So how am I going to work out that length? Well, this comes back to our discussion about those scale factors earlier. So we've got the small pyramid at the top, and then we've got the larger pyramid at the bottom. Well, do you remember that we said to go from the small pyramid to the large pyramid, we have to multiply by 3. So if you think about it, this has 3 parts, this has 1 part here. So this length here will be 1 part out of 3 in total of the entire length here. So it will be 1/3 of this number. But that's not what I'm looking for. I'm not looking for this length. I'm looking for this length here. So if this is 1/3 of that length, this must be 2/3, 2 parts out of 3 of that entire length. So that's why I'm multiplying this length AC by 2/3 here to get this number. Okay, that's brilliant. So that's going to help me to work out the total surface area of this shape. Right, so we need to find the total surface area of this frustum. So remember we said there was a green square at the top. That's a 13 by 13 square. There's the blue square at the bottom. That's the 39 by 39 square. And then we have 4 of these trapezia. And we know, if you remember, that this length at the top here was 13. We worked that out earlier. This length at the bottom, the other parallel side, is 39. And we just worked out that perpendicular height, that was 32.69. So, putting it all together, we've got a 13 by 13 square, plus a 39 by 39 square, and then we've got 4 times the area of each individual trapezia, which is given by half times A plus B, so you add together the 2 parallel sides, multiplied by that perpendicular height that we worked out earlier, the 32.69. Put all of that into your calculator in one go and you get this number, and then we just need to remember that we need to give our answer correct to the nearest whole number at the end. And the units would be centimetres squared, not cubed, because it's not a volume, it's an area that we've worked out.